Today we're going to look at finding the probability of several independent or several dependent events. A little review on simple probability. If you recall, simple probability is finding the probability of a single event, like rolling a die and trying to get a 5, rolling a die and getting an even number, or drawing one card to get a specific value like 6, or drawing a marble out of a bag and getting a certain color like blue. Compound probability is probability of several sequences of events. So that might be rolling a die twice, getting a 2, then getting a 6. It could be rolling 2 dice. It could be drawing 2 cards and getting a queen, then an 8. Or drawing a card twice. It could be trying to draw 4 marbles out of a bag. So compound probability is more than one event occurring in your probability experiment. Some events are independent of one another, which means that their events do not affect the outcome of the events following it. So if you have an example would be rolling a die, getting a 6, and then rolling again and trying to get a 5. Trying to get a 5 is not dependent on whether or not you did get a 6 on the previous roll or not. The events are totally separate and independent of each other. When you're calculating probability of independent events, you're just finding each of their individual probabilities and multiplying to get the overall probability of the two events. When you're drawing items like a card out of a deck of cards or items out of a bag, you're going to look so that it specifically says that they replace the items each time there is a draw. So of course that means that dependent events do affect what happens after each event. So famous example would be drawing 2 cards one at a time out of a deck of cards, and you're not replacing the cards as you're making the draws. So if you can visualize at the beginning where you'll have 52 cards to draw from, if you draw a card, you now have 51 cards total in the deck of cards when you're making your second draw. If you keep making a draw and holding out cards, your total keeps going down each time, and that's what is happening when you're setting up for your probability, is that your denominator or your total changes. So your events are dependent on one another. Here we're asked to identify if the situation is independent or dependent, and then find the probability. We are drawing 3 cards and finding the probability that we draw a queen, jack, and king. Notice the problem did not say with replacement, so we do assume that we're not replacing the cards as we're drawing them. We are drawing 3 cards, so we're going to have 3 multiplying fractions, and we start with a total of 52 cards. For the queen, there are 4 queens in the deck of cards, so 4 out of 52 is the chance for drawing a queen. When we're trying to draw the jack, which is the second card, we now have 51 cards. We still have 4 jacks in the deck of cards. And when we're trying to draw the king, we're now down to 50 cards. We still have 4 kings in the deck. And you multiply the numerators and the denominators and reduce. So the probability is 8 out of 16,575. Here we're asked to find the probability of drawing 2 cards with replacement, first getting a king and then a 4. So we are going to set up 2 multiplying fractions for the 2 cards. first card represents the king, second card are your fours. Your total you begin with is 52 for total cards. 4 are kings. Since we're replacing, we still have the same total in the denominator. We still have 4 cards in the deck that are fours. And then we multiply the tops and the bottoms. And then reduce your ratio. Calculators are very helpful. I can help you with that in class. 1 over 169. Here we are drawing 4 cards. What's the probability that they are all face cards? Again, they're not saying they're replacing, so there is no replacement, which of course makes this the dependent scenario. And we're going to have 4 multiplying fractions. And each of them represents your face cards. We start with a total of 52, and then since we're not replacing, each draw is down by 1, so we know all our denominators are going to go down by 1, down by 1, down by 1. Your face cards are your queens, jacks, and kings. So we have 3 times 4. We start out with 12 face cards. And then since we are not replacing, those values go down by 1 as well. So we start with 12. In the second draw, we have 11 face cards remaining, and then 10, and then 9. And you multiply your numerators, multiply your denominators, and reduce. 99 out of 54,145. Last example we'll do, drawing 2 cards once again. With replacement means we have the independent scenario, 2 multiplying fractions. 1 represents your 2's. The second one represents getting a 3. We start with 52 cards. In the second draw, we'll have 52 again because of the replacement. And we have 4 cards that are 2's, 4 cards that are 3's. Multiply and reduce. And so that probability again is 1 out of 169.